Okie dokie. Artichokes. I'm just keeping on going. This may be a new day for you, and that's good. Our review for the semester final for pre principles of pre-calculus for chapters 2 and 3. So the second half of our review, describing functions. And we got a little new one in here and a new one that I just wanted to add in. I'm not going to test you on them, but I wanted to throw them in so we can start thinking about it. Okie dokie. For next semester. So giving you a little preview maybe. All right, so we'll make these arrows look a little nicer. All right, domain and range. We should be starting to get pretty good at this. Domain is what works for X, what X values can exist, and it looks like all real, right? We go forever in both ways, forever this way because of that arrow, looks like forever this way because of this arrow. There's no asymptote restricting it, right? So I'm going to assume it's all real. We're going from negative infinity to positive infinity. Either one of those would be fine. Okay. For range, it's what works for y values. So I'm going to go down to see where we start. And oh, the y values go forever negative, right? So that's negative infinity. And it goes up till, oops, we need a number here. Let's make this 2. Okay. Um, so we'll make that 2. And it looks like at this point it goes 2 and it's like constantly here. So we go up to 2, but we don't get more than that. But it looks like it's equal to it. So I'm going to go with that. If you said, I don't know if it's equal to it or not, and you did that, that'd be fine. You could also write y is less than or equal to 2, right? Y values less than or equal to 2 are the ones involved. So either one is fine, right? You could do whatever you want there. Okay, dokes. All right, x and y intercepts. So x intercepts, I'm looking for where it crosses the x-axis. Definitely at 3, right? I'm assuming these are going by ones. It looks pretty close. I'm just going to make it a bigger dot here. Looks pretty close to -1. And this is like, so -1, -2, -3, -4, -4 and a third, right? I'm okay with you kind of estimating what it might be. -4.5, between -4 and -5, something like that, right? All right, my y-intercept, I'm going to call this -1. I wish we had numbers there. Sorry. All right, increasing, decreasing, or constant. Now, constant's new, but I bet you could figure it out. Yeah? All right, so let's try increasing. Remember, we get on the left side and we start riding the roller coaster. So it looks like it increases from forever down here. So from negative infinity, so x values. Okay, these are always talk about x, not y. Okay, so not y. We're using our x values. So negative infinity, x, all the way up to negative. It looks like -3. We are increasing. Cool. Do we increase again at any point in time? Yeah, we increase starting here, right? Until we get to here, which is 4. So from 1 to 4, we are also increasing. So 1, comma 4, we are also increasing there. All right, decreasing. I think there's only one place where we're decreasing. That's kind of nice, right? It goes from here at -3 until we get to 1. So from -3 to 1, we are decreasing. All right. What do you think's happening here at 4 and beyond? That is constant, right? So constant is going from 4 all the way to positive infinity. Okay, so that's a new one for us, but we see that it's a flat line. It is staying constant between those, or from there and on. Cool. All right, local mins and maxes. I've got one local min and one local max. What is this going to be right here? This is a max. So when we do local min or max, do an XY coordinate. So my max is at -3, 1. My minimum looks like it's over here at 1, -1. Okay. This over here is not a max. I mean, it hits a plateau, but any point at this plateau, remember to be an actual max, right? Where you're standing, it has to go down on one side and down on the other. Okay. And if I'm standing here, it's the same. It's flat ground. If I'm standing here, it's the same to my right, but it's going down and left. So that's not technically a max. Okay. So there will be no max over here. Okay. Sorry. Um, yeah. So there we go. Is it continuous? Okay. So continuous is if I start on the farthest left side, do I have to ever lift my pen to draw this? The answer is no, right? And if the answer is no, if I never lift my pen, it is continuous if I never lift my pen. Oops. It's continuous. Wow, you can't even read that. You're like, thanks, Mr. Reebok, for bringing that up. Your writing is illegible. This says it's continuous if I never lift my pen. So yes, it is continuous because I can trace along it and I never have to lift my pen up. Okay. So that's something we'll be talking about second semester. So these two things, continuous and constant, we don't have to worry about for now, but you will in a little bit. It's not that hard, right? It's not that. All right, unit circle and solving trig equations. All right, so quickly being able to do your unit circle, 0, 30, 45, 60, 90. We've got 0 or 2 pi, but because we're in the first quadrant, I'm just going to do 0. And then I got pi 6, pi fourths, pi thirds. You could pause this and see if you could do it. This point is 1, x, y, 0, and this is 0, 1. And then we do over 2's on all of these. And we go 0, 1, 2, 3. Add the square roots. 0, 1, 2, 3. And there we go. We got it all. Perfect. It's fast. We should be able to do that in like 30 seconds. Because now we can answer these questions. What's the sign at pi halves? So here's pi halves. Remember, it is cosine sine, right? So I'm looking for the y value at pi halves. Pi halves, y value is 1. Cosine at pi 6. Okay, so here's pi 6. Cosine is the first one. Oh, root 3 over 2. And I'm just going to leave it like that. I can't add those together. You could make this 2 over 2. So if you wrote 2 plus root 3 over 2 and combined it into one fraction, that's fine. But you don't have to. All right, tangent at pi thirds. Remember, that is sine at pi thirds divided by cosine at pi thirds. Okay, kind of a tricky one. So I'm going to go to pi thirds right here. Oh, sorry, that's pi 6. Pi thirds right here. And I'm going to go sine, which is root 3 over 2 divided by cosine there, which is 1/2. Okay, and we've talked about how to cancel fractions out or simplify them. I can multiply by the denominator, top and bottom. So times 2 on the top, times 2 on the bottom. Half times 2 is just 1. So that cancels out. Root 3 halves times 2 over 1. These 2's cancel out. So I get root 3. Boom. All right. Where is cosine? So what angle is cosine of that angle equal to root 3 over 2? So cosine's the first one. So look for root 3 over 2 here. Ah, there it is, right? So what angle is that? 30 degrees or pi 6 radians. I'll write both just so I get the practice. Awesome. All right. Graphing sine on cosine with transformations. So 2 sine 2x plus 1. There's 3 different transformations. So the first one is amplitude is equal to 2. It's a sine wave. So it's starting in the middle, going back to the middle, and then ending in the middle. It goes up first, down second. Okay. So its amplitude is 2. It's instead of going to 1, it's going to go to 2 or 2 above the midline. 2x here means my period is equal to 2 pi over b. So my period is going to be pi. And then this last thing means we're moving everything up 1. So my new midline is going to be at 1. Okay, so we moved everything up 1. So my midline goes up 1. And we'll go through a whole period by the time it gets pi. So sine starts on the midline. It ends at the midline. And halfway in between, it hits that midline in between, right? In between, it's going to hit its high point, which is not 1 over because of the amplitude. It's now up 2. And from here, it's down 2. So here is 1 period of y equals 2 sine of 2x plus 1. That was a nasty one. It's got three different things going on. It's not nice, Mr. Reboff. All right, negative means we are flipping up and down. So usually cosine goes like this. Negative cosine, however, is going to go like this. Okay, so negative cosine is going to start at the lowest, go up, and then back down. Okay, cool. Plus pi halves. Oh, dang, that means it's going to move left by pi halves. That's really mean because I don't have anything going this way. Oh no, Mr. Reboff, we're gonna have to guess. So it looks like pi halves is gonna be 3 boxes. So there's 1 box, 2 box, 3 box. So we'll just make this go over a little bit more. That'll help us out. All right, so cosine, this is not moving up or down, so the midline's still here. So it's going to start at -1. I'm just going to make this -1 and this +1. So we're going to start at the lowest, which will be -1 here, right? It will end 2 pi later. So it was going to end here at 2 pi, but we moved everything where? Left by pi half. So we're going to end here, right? Halfway in between these is now pi halves. It used to be pi. It's now moved here. And that's when it hits its high point. Yes. And then halfway in between, we've got the points in the middle. This one was kind of mean, Mr. Reboff. Can't believe you did that. There we go. Cool, cool. All right, here we go. Simplifying fractions. Ew, ew. All right, so two different ways to do this. I think the easiest way is to look at those denominators. What's the least common denominator would be A times B. So I'm going to multiply that on the top and the bottom. Okay, so I have AB over A minus AB over B all over AB over A plus AB over B. And can I simplify? Yes. Giant 1, giant 1. So on the top, I get B minus A. On the bottom, giant 1 over B plus A. And that, my dears, is as far as I can go. Cool. Cool. All right. We're getting there. Only 2 pages left. We're like halfway done with this. This is great. All right. Polynomial division. Ooh. All right. The setup is the first part, x minus 1 divided into x cubed. I see an x squared minus 2x squared. I know sometimes we skip, right? So we need to make sure x to the third, x to the second, x to the first, we're good. So I'm just going to copy that down. There's no holes to add a 0x or 0x squared in or anything like that. So awesome. We got it. All right. So what times x is x to the third? That's x squared. Now I multiply this times this. X times x squared is x cubed. Then I multiply x squared times minus 1. So that's minus x squared. Mr. Reboff's favorite thing to do. Change the signs and then add straight down. Okay, so change both signs. Those get eliminated. Negative 2x squared plus x squared is negative 1x squared. Take the next one down, plus 3x. All right, now I look at this first thing, negative x squared. So what times x gives me negative x squared? Well, it's got to be negative, and it's got to be x. Negative x times x is negative x squared. So let's multiply. Negative x times x is negative x squared. Negative x times negative 1 is positive x. Then there we go. Let's go ahead and change the signs. This becomes a plus. This becomes a minus. And then let's add down. Those cancel out. 3x minus x is just 2x. And then bring down the last part, minus 3. All right, so what times x gives me 2x plus 2? 2 times x, 2x. 2 times negative 1 is minus 2. For the last time, change the signs. Add down. Cancels, becomes negative 1. And negative 1 is my remainder. So I could write it as remainder 1. It tells me something. Or I can go x squared minus x plus 2, and then minus 1 divided by x minus 1. I would also accept for now x squared minus x plus 2, remainder negative 1. Either one of those would be fine because the remainder is important. It tells us something. Okay, we'll find that out next year. By next year, I mean January. Okay, this will tell us something really important, probably better than this. Okay, so here we go. Synthetic division. I take whatever would equal or make this equal to 0. So x minus 1, 1 would make that 0. Okay, then I'm going to take the coefficients 1, -2, 3, and -3. Cool. I've got that set up. So no x's anywhere. Don't have your x's in synthetic division. The whole idea of synthetic division was let's get rid of the x. They're pain, right? So free pass for the 1. 1 times 1. I'll even write this in. Times. This is times. So you multiply here. 1 times 1. That number goes there. And then we always add down. So -2 plus 1 is -1. 1 times -1 is -1. Add down 2. 1 times 2 is 2. Add down. That's -1. So my last one, I kind of shut it out a little bit. Remember, we started with x cubed. We're dividing 1x out. So what we have left is x squared. This would be the x's minus x plus 2. And then we have the remainder of -1. Okay, does that look familiar? Should look exactly the same, right? Exactly the same. Again, you could write it as x squared minus x plus 2 minus 1 over x minus 1. That's fine if you want. Either one's fine. Again, I think leaving the remainder is going to be better most of the time, okay? In terms of graphing later on, it'll tell us something cool. All right, final thing. Woo! Word problem. So we got a work problem, a dirt problem, and a number puzzle to do. Okay. So we talked about the 5-step method, right? I know some people like to use highlighters for things. I think that's great, right? 8 minutes together, right? So Mr. Mabeza can eat a bag of Takis in 12 minutes. So if he has 12 minutes, he will eat one whole bag, right? Mr. Sugden can eat the same bag in 8 minutes. So if he works at 8 minutes on those Takis, he's going to have it done. He's going to have one bag done. How long would it take if they ate the bag together, right? So they're going to be working together. So let X equal the time that they eat together. So we don't know how long Mr. Mabeza eats, but every minute that he eats, he's going to eat 1/12 of the bag. So 1 minute, 1/12, 2 minutes, 2/12. If he gets to 12 minutes, he's eaten one whole bag. 12 out of 12 is 1, right? We're going to add that to Mr. Sugden. Mr. Sugden eats for the same amount of time. They're eating it together, same time, right? But he can eat a bag in 8 minutes. So if he eats for 1 minute, that would be 1/8 of a bag. 2 minutes would be a quarter of the bag or 2/8 of the bag, right? Makes sense? This is how this is set up. And we are combining to eat one bag. All right, here we go. To solve this, I think a nice, easy way is to find a common denominator. It doesn't mean you could do 8 times 12 and multiply that here. That's perfectly fine, right? And if you want to do that, that's cool. You may have noticed that 24 might be an easier number to multiply by. That's fine as well. It doesn't matter. Okay, we just need a common denominator. And the easiest common denominator is just multiplying these together. So that's 96. So 8 times 12 over 12 is going to be 96x over 12 plus 96x over 8 equals 96. This reduces to 8. This reduces to 12. And that is just 96. So 20x equals 96. So divide both sides by 20. 96 divided by 20. I'm going to grab my calculator. Hey Siri, what is 96 divided by 20? It's taking its sweet time. Why is it taking so long? What is 96 divided by 20? I think it's 4.8. It's 4.8. I'm just going with it. Siri's not telling me anything. I'm sick of you, Siri. All right, here we go. Next one. Distance, rate, time problems. Ooh, school's almost out. I better hurry. A boat travels 24 miles upstream and 24 miles downstream. So as soon as we see a dirt problem, we're typically going to be comparing distance equals rate times time for two things. This looks like upstream and downstream. So up and down. The distance is 24 miles for both of them. Perfect. That's great. In a total of 5 hours. So time equals 5 hours. So this plus this equals 5, right? The speed of the boat in still water, right, is 10 miles an hour. What is the speed of the river current? This is a tricky one, right? This is a tricky one. So speed of the boat in still water is 10 miles an hour, but up they get an extra little hit, right? Going down, they get the other hit. I don't like this problem. Let me pause for a second. I might change it. Here we go. It doesn't end nice, I don't think, but it might. We'll find out. All right. It doesn't end pretty, but I'm going to go with it anyways. All right. So sometimes we can switch things up. I know that this plus this equals 5. So if I can have t solved for, t is equal to, I could add this plus this, and I know they're equal to 5. That can become my equation. So what is t equal to, though, if I wanted to solve for t? What would I have to do to this r? They're multiplying right now. Divide. So t is equal to d divided by r. So I'm going to change my dirt to dutter. Okay? So for the first one, upstream, it's going to be 24 divided by 10 minus c. And upstream, it's going to be 24 divided by 10 plus c. Okay? So this plus this has to equal 5. And now I've got my equation. All right, so let's do it. 24 over 10 minus c. And then we're going to add 24 over 10 plus c. And that's going to equal 5. All right. So we've got our equation set up, right? And it's really ugly. So do you remember what we did on the other page? How do we eliminate fractions? Yeah, we multiply by the common denominator. So I'm going to multiply both sides by 10 plus c and 10 minus c. Okay, so this is going to get hit with 10 plus c and 10 minus c. Sorry, I would usually put them next to each other like this here. But these both are going to distribute here and here. Okay, when this distributes here, the 10 minus c's will cancel out. So I have 24 times 10 plus c. And then when I distribute here, the 10 plus c's will cancel out. So I'll have 24 times 10 minus c. And that equals 5 times these multiplied by each other. If I have something plus something and something minus something, that's a difference of perfect squares, right? So that's going to be 10 times 10, which is 100, minus 10c plus 10c, the middle terms cancel out, and then minus c squared. Cool, cool. All right, let's distribute here and here and here. It's a lot, right? I told you this problem was ugly. That's why I paused, but that's okay. Plus 240, 224 minus times minus c is minus 24c equals 500 minus 5c squared. Okay, does that look pretty good? I think so. I think so. Let's find out. Let's see. We got 480. Oh, the c's cancel out on this side. So 480 equals 500 minus 5c squared. All right, so we're going to subtract 500 minus 500. So I'm going to get negative 5c squared equals negative 20. Divide by negative 5c squared equals, oh, hey, this ain't so bad. So c is going to have to be 2. So the speed of the water is 2. And that's what it asks for. What is the speed of the river current? C is equal to 2. All right. Think that works. Yeah, I think it does. So we could do a quick check. 24 over 10 plus 2 plus 24 over 10 minus 2, is that equal to 5 hours? 24 over 12 is 2. 24 over 8 is 3. We are good. So the speed of the current must be 2. That was nasty. That's probably a little bit harder than what I would throw at you on an exam. But we see how distance, rate, and time works, right? It's a good thing. All right. This one will be a little bit better, I hope. Sum of the digits of a two-digit number is 11. So sum of the digits. So we have two different digits, right? We have the ones digit and the tens digit. So let's let t equal the tens digit. It's traditional, right? And then u will be the units digit or the ones digit. That's the way a lot of people do this. You could use x and y if you want, that's fine, right? So it says the sum of the digits is 11, easy peasy. We got t plus u equals 11. I've got my first equation, okay? Equation number 1 right there. It says here, if you reverse the digits, the new number is 45 less than the original. Well, what was the original number? Original number was the tens digit times what? Times 10. So 10t plus u, right? That's the original one. The new reverse digits is going to be 10 times whatever the u is plus t, right? So if it was 23, the tens digit was 2. 2 times 10 is 20, plus the ones digit of 3. Now we've got 10 times 3 plus t, so that plus 2, so that'd be 32. 23, 32, reversed. Make sense? Cool. All right. So if we reverse the digits, the new number is 45 less than the original. This is 45 less than this. So here's what I do. I'm going to make them equal. 10t plus u equals 10u plus t, right? Now, to make them bounce, because they're not balanced, right? This is 45 less than this. So if this is a teeter-totter and this is 45 pounds less, right? How do I make them even? I add 45 to this, right? So I'm going to add 45 to the side that's less. And now they're even Steven. Now this is true. All right, so what am I going to do? I'm going to subtract 10 and a t from both sides. So minus 10u minus 1t. So I get 9t minus 9u equals 45. I notice everything here is divisible by 9. So what if I do that? What if I do a quick that? T minus u equals 5. All right, so that's my other equation. Let's put it up here. T minus u equals 5. Are you having any vibes with these two? Are you feeling it? Are you feeling a little like elimination? Yes, 2t. U's cancel out equals 16. So t must be 8. All right, and if t is 8, 8 plus what number is 11? U has to be 3. 8 minus 3 is 5. It works for that one. There we go. So what must be the number? If tens digit is 8 and the units digit is 3, 83. Right? And then we can do a quick check. 83 minus 38, is that 45? Question mark? Yes, it is. All right. That's it. You did it. The whole first semester. I know the last page got a little funky and scary, but everything else I think you've got down. We just need a little more practice with that. Come see me if you need that. All right. That's it, people. We'll see ya. Bye.